If you're anything like me, you'll often become lost in thought considering the hopes and dreams of a giant squid. What motivates a razor clam to get out of bed every morning? Is the relationship between freshwater snails and marine snails one of jealousy or mutual respect? If these questions keep you up at night, you're probably a weirdo. But that just means you clicked on the right video. Meet the Phylum Mollusca, the most innovative and biodiverse animal group that we've covered so far, including between 85,000 and 150,000 different species. Even on the low end of that estimate, this means that there are more species of mollusks than there are species of fish, amphibians, reptiles, birds, and mammals all combined. When an animal is this numerous, it usually means they're doing some pretty cool stuff. But what makes a mollusk a mollusk? What can they teach us about our oceans, both past and present? And what are the octopuses planning? We'll find out the answers to all these questions and more as we continue exploring the Tree of Life. The word mollusk comes from the Latin word mollis, which means soft. Kinda ironic considering how many of them have shells, but whatever. There are 8 classes within Phylum Mollusca. Gastropoda, the snails and slugs. Bivalva, the clams, mussels, and their delicious relatives. Cephalopoda, the big brain gang including squid, octopus, cuttlefish, and nautilus. Polyplacophora, the chitons, whose Latin name literally translates to many plate-bearing due to their badass segmented shells. Scaphopoda, the tusk shells, weird little guys that like to hang out 6,000 meters below sea level. Monoplacophora, a class known as cap shells that were thought to be long extinct until a live specimen was discovered in 1952. And then there's these two, class Caudofoveata and class Solenogastris, both of which are understudied, worm-like, and confusing. Looking at an oyster and a cuttlefish side by side, it's tough to see how they can share any physical traits. However, all mollusks have a mouth, an anus, a foot, a mantle, and a big sack of organs called a visceral mass. The mouth and anus are pretty self-explanatory, but they're worth mentioning because up until now, every phylum we've covered eats and excretes using the same hole. So you can kiss a snail on the mouth without getting poopy breath. Isn't that nice? The foot of a mollusk, as you might have guessed, is used for movement. In gastropods, chitons, and cap shells, the foot glides over surfaces using waves of muscular movement. Bivalves and tusk shells use their foot like a spade to burrow into the sand, and the cephalopod foot has transformed over evolutionary history into at least 8 arms that surround the mouth, used for movement and capturing prey. The mantle is a layer of tissue that's responsible for forming the hard external shells of most mollusks, as well as the internal shells of squid and cuttlefish. Beneath the mantle is the appropriately named visceral mass. Most of a mollusk's internal organs are found there, safely tucked away under their shell. In the case of octopuses, the visceral mass makes up the bulk of this large bulbous region, while the central brain is actually located between their eyes. You may have noticed that I just said central brain, and that's because octopuses actually have 8 additional smaller brains at the base of each arm. That's why octopuses do thinking so smart. On the opposite end of the cognitive spectrum, bivalves and gastropods have no brains. And that really sucks because I had a clam do my taxes this year. While cephalopods were evolving more complex thinky parts and bivalves were bivalving, gastropods were busy with a different agenda: life on dry land. Mollusks have a global range, and the majority are marine, although a few bivalves and gastropods live only in fresh water. Gastropods are the only members of this phylum that have made the evolutionary leap onto dry land. But fingers crossed the octopuses figure it out soon. Like their aquatic relatives, snails and slugs on land are mostly scavengers and detritivores, consuming rotting vegetation, bacteria, and fungi, although carnivorous and herbivorous species are also common. Unlike the completely carnivorous cnidarians and ctenophores, mollusks have a very diverse diet that varies between classes. Chitons are mostly herbivores, grazing on algae and seaweed, although some species will also enjoy a delicious barnacle or sea sponge from time to time. All cephalopods are predatory carnivores, either ambushing their prey or actively chasing it. That's where those big old brains come in handy. Now bivalves, let me tell you about bivalves. Much like our old friend the sea sponge, bivalves are quite literally living filters. They create a current using cilia on their gills, taking in water from their environment and filtering out anything over 1/1000th of an inch in diameter. Bivalves are such efficient filter feeders that they often have dramatic effects on the water quality in their habitat. As they feed on plankton and algae, they also remove excess nitrogen and other harmful toxins from the water, which not only makes water clearer, it also improves the overall health of every other organism they share space with. And guess what, dude? That includes you and me. Oysters, for example, are some of the most effective living filters on the planet. Just one oyster can filter 50 gallons of seawater per day. They also happen to be one of the most sustainable food sources. While most animal agriculture has been found to negatively impact the environment, oyster farms have the opposite effect, improving the water quality around them as they grow. As a bonus, oyster farms produce pearls and shells for the jewelry trade without taking anything out of the wild. Farmed oyster meat is so environmentally friendly that vegans will often make an exception to include it in their diet. And did I mention that it's incredibly nutritious? Because that's also nice. We're not alone in enjoying meals of mollusks. They can fall prey to pretty much anything that can catch them and break open their shells, often including other mollusks like predatory snails, octopuses, and cuttlefish. Even after the animal inside has been eaten, the shell they leave behind provides shelter for other animals. Hermit crabs rely on the shells of dead gastropods for protection, and some African cichlids exclusively raise their babies inside freshwater snail shells. Mollusk shells can also teach us a lot about Earth's history. The extensive fossil record left behind by extinct gastropods and cephalopods provides valuable information about past environmental conditions in marine ecosystems, which can give us a better idea about what the future of those ecosystems might have in store. Marine mollusk shells are the most commonly found fossils on Earth, and on top of their scientific importance, they're just really cool. Almost as cool as the animals that lived inside them hundreds of millions of years ago, and the ones that we still share the planet with today. Next week, would you still love me if I was an earthworm? How about if I was a leech? What if I was a 9-foot-long predatory bristleworm with scissors for a mouth? You don't have to answer right now. Wait until Friday, when we get to know the segmented worms of the phylum Annelida. Until then, stay curious, stay connected, and never stop evolving.
Thank you.